So the next algorithm we'll be talking about is quicksort, and quicksort is, on average and its best case scenario, it's O of n log n. However, depending on how you perform the algorithm, it could become an O of n squared algorithm. But generally, it's an O of n log n algorithm. The basic idea of quicksort is to choose a pivot, which in this case will be our middle element, and move all of the elements less than the pivot to the left side of the pivot, and all of the elements greater than the pivot to the right side of the pivot. And essentially, that means the pivot will be in the correct place. And after that, you'll recursively apply this to the separate arrays, not excluding the pivot. So on the left side and the right side, respectively. So we can do this in the following manner. So in this case, we'll take the middle to be the pivot, which is 4. And then we'll start from the rightmost and the leftmost, and we have 6 and 3. Since 6 is greater than 4, which is greater than 3, you will swap 6 and 3. And then we continue, we'll decrement, and this these are all in the right place, and these are all in the right place. So we take the pivot, since it's in the right place, and have these two arrays. Then we choose, I'll be focusing on this array for now, but when we'll do it for this one after. So we take the pivot to be 1. Since 3 is greater than 1, you'll move it over here. And now 1 isn't in the right place. And then you'll do the same thing. We will take the pivot to be 3. Since 2 is less than 3, you move 2 here. And so now these both are in the right place, and they're both 1, so you can put them back into here. We do this for this side too. We take 5 to be the pivot. And since 7 is greater, you'll move it in to here. And then, so 5 is in its right place. And then between 7 and 6, if we take 7 to be a pivot, and 6 is less than that, and then we take these two and move them in here, and then we have our sorted array.